Hello and welcome to a new video. This is for Algebra 1. We're solving quadratic equations still. We're on lesson 3. And this is where it's going to get a little complicated if it wasn't already complicated, which I guess depends on you, whether or not you felt like this has been complicated the whole time or not. This time we're going to learn a method that works no matter what. So for our warm-up, we're going to go over the two methods we've already learned for solving quadratic equations. The first one only works when there's not an x term. So for it to be a quadratic equation, you have to have an x squared or some other letter squared. But if there is an x term, that changes what we are allowed to do. So A on our warm-up here does not have an x, just a regular x, which means that we can solve this by getting x squared by itself and then taking square roots. So we're going to solve this like we do a linear equation by adding 50 to both sides and getting 2x squared equals 50. Then we divide by 2 on both sides and get x squared equals 25. And then the difference between a linear equation and what we have here is a linear equation, we would have x equals 25 and that'd be our answer. But now we have to go a step further and say, well, what can x equal if x squared is 25? So what number do we square and get 25? Or in fact, there's actually two numbers that we square and get 25. And one way you can think of it is that we are square rooting each side to get rid of that square. So we square root 25 and get 5, but that means that we actually get a positive 5 and a negative 5, because both of those things, if you square them, will give you 25. If we have an x term, we learned last lesson that there is something we can do to solve that is, I guess, relatively easy, depending on how good you are at factoring. Because if I have x squared minus 9x plus 18, I can't solve for x as in get x by itself the way it's written right now. But I can look at this and say, well, wait, is there something that multiplies to get 18 but adds to get negative 9? And if there is, then this factors into two parentheses. So let's see, 18. How about 3 and 6? And so that would be a minus 3 and a minus 6. So what we can do now that we have x minus 3 and x minus 6 is we can say, well, if these two things multiplied together have to equal 0, either x minus 3 has to equal 0 or x minus 6 has to equal 0. And that's how we get our two answers. And in general, by the way, when you have x squared, you're going to most of the time get two answers. The vast majority of the time, you'll get two answers. So to finish solving this, we add 3 and get x equals 3. We add 6 and we get x equals 6. So that's our two answers, 3 and 6. And we can't write those as like a plus or minus thing because they're not the same number, but positive and negative. So we just make a list of them and say it's 3 and 6. So this is what we've already talked about. These are basically two situations that are very special. And so now we need to address what do we do in other situations. So there's actually kind of 3 other methods, I guess, that we can use to solve quadratic equations. One involves graphing, which we haven't talked about yet. And it also is kind of a special case, kind of like square roots and factoring. Then the other two that you can basically do anytime you want are what we're going to learn today, which is solve using the quadratic formula, and then something that I usually save for later, which is called completing the square. So when we look at this equation, x squared plus 4x plus 2, and we think, how would I solve this? Well, there's an x term, so we can't use square roots just to like solve for x or solve for x squared and square root both sides. We could check to see if this factors. Is there something that multiplies to get 2 that adds to get 4? The answer to that is no. So then we're stuck with what we know so far. So there's this thing called the quadratic formula. You can, enjoy how mathematicians name things that it's not a very creative name, but it definitely tells you what it's for. The quadratic formula will solve any quadratic equation that you have. it does look a little bit complicated. I would imagine that this is the most complicated formula that you've seen up to this point in math. So what we do is we have to have our quadratic equation in standard form, which means it needs to be all on one side with equals 0. And then we want it to be x squared, then x, then our number. And if it's in that order, we can label the coefficients of each of our terms, which is the number part of each of our terms. We can label those A, B, and C and then plug it into this formula. I was thinking about this earlier, and we could do the same thing actually with linear equations and make a linear formula, but it actually would be at least as much work, if not more, to use the linear formula that we'd come up with than just to do what we normally do to solve a linear equation. If you think this is complicated, take a look at the cubic formula, and that's complicated. So you're gonna find out in Algebra 2 how we solve things with x cubes in them, and it's not by using the cubic formula. I've tried one time in my life to use the cubic formula to solve something, and it did not go well. So I'm just throwing that out there, that yes, this is complicated, but this is doable complicated. One of the things that is likely going to be an issue here is that in order to use this formula, you will need to have it memorized. So I actually have a couple videos that I'm going to put in the description. If you would like a rap version to try to memorize, I'll put that link. Or this one's a more normal version, I guess, is you can put this to the tune of Pop Goes the Weasel. And I just made a video right like last night of me doing the quadratic formula to Pop Goes the Weasel, accompanied by my child's piano book. So check those out if you'd like a song to help you remember it. I did not know about these songs whenever I memorized the quadratic formula, but now that I do know the song, I do sing the song in my head, because I especially like the end of it that goes all over to A, which is the end of Pop Goes the Weasel. So this is a formula, work on memorizing it, and now let's talk about how to use it. So I've got it written down up here in the corner of my slide so that I don't have to like rewrite it on each slide. This is what we're plugging into, and here's how this works. The number in front of x squared is A. The number in front of x is B, and the number that doesn't have an x squared or an x is C. And all of the ones I'm giving you today are going to already equal 0. If they didn't equal 0, that would be our first step, is to solve for 0. Now, x squared doesn't have a number in front, so we know that's really a 1. X has a 9 in front, and then this last number is 14. If any of these were negative, we would take the negative with it. It just so happens these are all positive. Now let's plug this in. X equals, I'm going to make a big fraction, negative b. So b is 9, so negative b would be negative 9. Now there's going to be an issue here, right, where if b was negative and we put it in, it switches it to positive. Then we're going to make a big square root sign. B squared, so 9 squared, minus 4ac. That means we're timesing these together, so 4 times a times c, like so, and then all over 2a, so 2 times 1 goes on bottom. Now, we could technically put this in the calculator. We can't put it with a plus or minus sign, but we could put negative 9 plus the square root of blah, blah, blah over blah. And like we could find decimals, but we are going to do this mostly without our calculator and trying to find it as a radical if necessary, a square root if necessary, instead of getting some decimal. So there's a process that we typically go through to make that happen. The first thing we need to do, or one of the first things we need to do, is say, okay, what do I get if I do 9 squared minus 4 times 1 times 14? So order of operations, which is PEMDAS, says do exponents first. So 9 squared is 81. Well, actually, it says to do parentheses first and then exponents. And then it prioritizes multiplication over subtraction. So we're going to take 4, 1, and 14 and multiply those together. Or you could think of it as negative 4 times 1 times 14, which is going to give us a minus something. We basically need to figure out what 4 times 14 is, because times 1 will just give us whatever we have. So I'm going to come over here and do 4 times 14 and get 56. All right, so now what do we get if we do 81 minus 56? 25. Oh, that's nice. So this, what's under the square root now is going to be 25. On the bottom here, 2 times 1 is 2. And then we're ready to kind of do our next step of simplification. So as you're doing this, like, that is likeliest the part that you'll mess up on is what's under the square root. You could take the 9 squared minus 4 times 1 times 14 and put it in the calculator and have it do that part for you. Just make sure you type it in correctly. You don't want to include the square root, or if you do include the square root and it gives you a decimal answer, then you want to try it without the square root. In this case, we have square root of 25, which would give us 5. So our next step is to write that. Negative 9 plus or minus 5 over 2. And now we say, okay, plus or minus means I actually have 2 answers. I have one where I do negative 9 plus 5 over 2. And I have a second one where I say negative 9 minus 5 over 2. So negative 9 plus 5 would be negative 4. And negative 4 divided by 2 is negative 2. So one of my answers here is negative 2. The other answer, negative 9 minus 5, gives us negative 14. Negative 14 divided by 2 gives us negative 7. So our 2 answers are negative 2 and negative 7. Now I'm going to be honest with you. If we get a nice answer like this, like whole numbers, integers, whatever you want to call them, even if we get nice fraction answers, this actually means that we could have factored. So if we look back at the problem, and you may have realized this at the beginning, there is something that multiplies to get 14 and adds to get 9. That's 7 and 2. So we could have split it into 2 parentheses and solved it that way. But just the quadratic formula is complicated enough. I wanted to show you kind of the process where we end up with something that's nice, because not all of them end up nice. The ones that don't end up nice are the ones that you'd have to use the quadratic formula to solve. So let's give another one a try. So here we've got example 2. We still got the quadratic formula, but our numbers here are different. And that's basically what's going to be the difference on these problems, right? Is that they're going to look a lot alike, but with different numbers in front of each of these. We're going to label A, B, and C. A is 4. B is a little tricky. Remember, there's a 1 there, so B is negative 1, and C is negative 16. So now let's plug in and find what x equals. This is the situation I was talking about in example 1, where B is negative, but it tells us to do negative B. So negative 1 becomes positive 1. So that's one of the first things we can do. And in fact, you can actually do that like without even having to write down the negative 1 if you'd like to. But that is something that's going to happen, is it changes whatever B is, it changes the sign of it at the beginning here. Plus or minus square root of. Now, if you are putting this in the calculator especially, that negative 1 for B squared needs to go in parentheses so that you're saying I'm squaring negative 1, so I'm doing negative 1 times negative 1, which is a positive 1. If you put it in the calculator and you don't put the parentheses and the squared on the outside, it will do it wrong. It's really annoying. Minus 4 times A, which is 4, times C, which is negative 60. All over 2A. So 2 times 4. Okay, so we need to figure out this part that's underneath the square root. Negative 1 squared is going to be a positive 1. Then we've got minus 4 times negative 60. I like to think of this as kind of 2 separate things. I like to look at this and say I've got negative 4 times positive 4 times a negative 60. So that's 2 negatives, which make a positive. one of the easiest places to mess these up is just putting the wrong sign right here. And then I'm going to do 4 times 4 times 60. So I'll do 16 times 60 and get 960. So 1 plus 960 is 961. I wonder if that has a square root. That's kind of a big number. I mean, not just like kind of, like that is legit a big number. And I feel like I purposely didn't, I tried not to give myself really, or us, really big numbers. That's 31. So, you certainly can have a calculator handy. If you're in a class of mine, you could certainly have a calculator handy to check things like that. If it had given us a decimal, instead, we would say, okay, well, how would I simplify that square root? But the square root of 961 is 31. So we go with that. And then we're ready at this point to split this up into two answers. X equals 1 plus 31 divided by 8, and x equals 1 minus 31 divided by 8. So that would be 32 divided by 8, which is 4. And this would be, oh, this one's a little tricky. Negative 30 over 8, which doesn't divide evenly, but we can simplify that by 2 and get negative 15 fourths. So this one actually we also could have factored at the beginning, but we would have had to use slide and divide or the box method or split the middle term or guess and check. Whatever method that you're familiar with, we would have to use that method. And so this is where you might actually go, okay, I know the quadratic formula works. I'm not great at doing slide and divide or the box method or whatever. And I'm not even sure that I can use it. So you might choose to use the quadratic method, even though it is possible that this factors. I mean, technically all of them, it's possible if it factors. It's just a matter of figuring out if it's factorable or not. For this one, if we were trying to do that, we'd have to, our key thing would be doing 4 times negative 60 and getting negative 240 and trying to figure out, is there something that multiplies to get negative 240 that adds to get negative 1? Now, I like doing math in my head, but I'm not super excited about the idea of figuring out the factors of negative 240 that subtract to give us negative 1, because it has to be basically, if I make like a strategic list starting with 1, it's going to be the very last one I come up with. I'm just going to do it real quick just to show you I can, because I'm curious. There we go, 15 and 16. So they're one apart. You'd make it be negative 16 and plus 15, and then use whichever of the methods you like the best. And you'd end up with parentheses, and you'd be able to get 4 and negative 15 fourths. But yeah, that's not one. Looking at this, I would not have been confident that I could factor it, and knowing how long it would take me to come up with the factors, I might have just decided to do quadratic formula anyway. So example 3. We have 5x squared minus 4x minus 8. You're welcome to pause and try to do this on your own, but there is going to be something different that happens. So you'll likely need to start the video back up, I would imagine, to see what we need to do here. So first off, we label A, B, and C. So A is 5, B is negative 4, and C is negative 8. Notice I just take the number. I don't take the x or the x squared with those. Now let's plug this in. X equals negative b, so a negative negative 4, which is going to turn into a positive 4. B squared, so negative 4 squared, minus 4 times 5 times negative 8, all over 2a. So there are two things that we can kind of do right off the bat here. The 4 on top and the 10 for 2 times 5 on bottom. It's the thing that's under the square root that's a little more complicated. Negative 4 squared is a positive 16. Whatever we get for b squared is going to be positive, because even if we're plugging in a negative, we're immediately squaring it. So we have a negative times negative, which makes it positive. Then we're going to do negative 4 times 5 times negative 8. So negative 4 times 5 is negative 20. Negative 20 times negative 8 is positive 160. So just to like reiterate, negative 4 times 5 gives us negative 20. And then we times that by negative 8 and get a positive 160. So 16 plus 160 is 176. Now, I don't think that has a square root. I could check on my calculator, and I'm pretty sure I get a decimal. But let's simplify this and see what we can get for a simplified square root. So 2 goes into 176 88 times. 2 goes into 88 44 times. 2 goes into 44 22 times. And 2 goes into 22 11 times. So the way that we simplify square roots is we look for pairs of numbers, because those are things that we can square root. We can square root 2 2's, which is 4, and we can get a single 2. We can square root these 2 2's and get a 2, which gives us 2 2's on the outside. And then our 11 over here is left over and has to stay inside of our square root. So the square root of 176 is 4 square roots of 11. And if that's something that's tricky for you, I definitely understand. I have a separate video, or I have multiple separate videos, actually probably technically, on simplifying square roots and how that process works, including one where I talk about it in Minecraft. So that's pretty cool. If you ask me, which you didn't, but it's fine. It's fine. Okay. 4 square roots of 11. Now, here's what we've got. We can split this up into 2 things. We can say this is x equals 4 plus 4 square roots of 11 over 10. And we can say x equals 4 minus 4 square roots of 11 over 10. There is one thing we can do to this, and this is kind of some trickiness as far as knowing what you can and can't do with square roots. We are not allowed to do 4 plus 4 square roots of 11 and get something else unless we plug it into our calculator and get a decimal. So we will leave those 2 things separate. Square roots actually work like terms, that if we had more than one square root of 11, we could add them together, just like we can add x's together. But because it's a 4 and then a 4 square roots of 11, we can't add or subtract those. But because of the 2 4's on top and the 10 on bottom, since those are all divisible by 2, I can actually divide all of those by 2. It doesn't matter what's in the square root for this, because what's under the square root is kind of protected anyway from us trying to simplify. So basically it ends up being this idea of, can I simplify 4 over 10 and 4 square roots of 11 over 10? Well, 4 over 10 we're used to. That's 2/5. But you actually can do the same thing with 4 square roots of 11 over 10, where we can say, okay, well, I can choose to cancel a 2 out of these 2 and get 2 square roots of 11 over 5. All that to say that one of our answers would end up as 2 plus 2 square roots of 11 over 5. The other would end up as 2 minus 2 square roots of 11 over 5. But in order to be able to simplify all 3 numbers, so the number in front of the plus or the minus, the number right after the plus or the minus outside of the square root, and the number on bottom, all 3 of those have to cancel. So that's how that works. This is a problem that we would not be able to use factoring to solve. We could use completing the square, which you don't know how to do, or we could actually use graphing, but that would also give us a decimal. So that wouldn't really be the way to go either. But that's kind of this is the other situation that we have here. This is kind of the unsatisfying answers we can get from the quadratic formula. But hey, they're still answers, which is good, right? I just realized that all of these examples say A because I just, I like copy my previous PowerPoint and use that to start my new lesson. And so the previous lesson had an A and a B on the examples. So if you were bothered by that this whole time, I'm sorry. I just now noticed that. So example 4, we've got A, B, and C. So A is for, isn't it nice how it goes, alphabetically in order if it's in standard form, which is the kind of form that we like, having x squared first, then x and then a number. I think it's nice. So we're going to plug this in. This one's going to work out pretty similarly to what example 3 did. So you're welcome to pause and try it on your own and then start it back up when you need help or when you have your answer. So x equals negative b. So negative 4 plus or minus square root of b squared minus 4 times a times c all over 2a. So nothing, we don't do anything with that negative 4 because it's just a negative 4. 2 times 4 on bottom is 8. But how about this square root? 4 squared is 16. Negative 4 times 4 is negative 16. But then we need to times that by negative 13. Notice I can't be like, oh, well, 16 minus 16 is 0. Because the negative 16 is attached to this negative 13. We have to do these together before we can add or subtract the two numbers. It will actually be adding because we have two negatives that make a positive. Oh man, what is 16 times 13? I just don't even know. But I'll find out using the powers of math. 168. So that's plus 168. 16 plus 168 is 184, I believe. So we need to simplify the square root of 184. We can check to see if it has a square root. It does not. I think 196 has a square root and 169 has a square root, but not 184. So what goes into 184? Definitely a 2 because it's even. That would go in 92 times. And then 2 goes in 46 times. And then 2 goes in 23 times. And 23 is prime. So we get a pair of 2s and a 2 and a 23 left over inside, which is 46. Now, that doesn't seem like a really great answer, and I get that. But it is what it is. So last time I had to split this up into two things. You actually can leave it as one thing. We can leave it because we're not going to get a nice answer anyway. So we could leave it as what looks like a single answer, but is really 2 because of the plus or minus. But we do still want to check to see if this simplifies. And we do that by looking at the negative 4, the 2 in front, and the 8. All of those are divisible by 2, so we're going to divide them all by 2. And get this for our answer. So, hooray! We did it! This is a quadratic formula! It's so exciting! Yeah! I do want to make a note, if you're still watching, that you should definitely, if you're like, man, I just can't get these answers, at least do the thing of, labeling A, B, and C, plugging it in, and doing as much as you can, because a lot of times teachers will give partial credit. So, it's better to see that you know at least, at what point is it not working, because then your teacher can help you from there, hopefully, but can also give you partial credit along the way, which is nice. Thanks so much for watching. I hope you enjoyed this video. Subscribe if you haven't already. Give me a thumbs up to say you like me, or that you like the video, or both, and I'll see you in the next video. Thanks!